4.5, graph using slope-intercept form. So far we've graphed by either just straight up plotting points or like finding a table and plotting points, or we have done it using intercepts where we were finding like the x and y intercept by using the cover-up method and doing it that way. So now we're going to be using slope-intercept form. So this is going to tie in 4.4 with graphing more specifically now. Finding the slope and y-intercept of a line so in words, and then I'll do symbols, and then I'll do a graph for you. So in words, a linear equation of the form y equals mx plus b is written in slope-intercept form where m is the slope and b is the y-intercept of the equation. So in symbols, we have y equals mx plus b. M is my slope. B is my y-intercept. So what this could look like is something like y equals 1/3 x minus, or well, let's just do this, plus 2. So as a graph, and I'm just going to do a little tiny graph here before I put up my graph lines. So what this would look like is I have a y-intercept of 2. So that means at this point right here, I put a point on the graph, and that's always going to be the first thing that gets graphed is this y-intercept value here. Okay? Then the slope, which this is where the questions that we were answering about like what's happening to the slope comes into play. So remember, slope is rise over run. So this means we go up 1 and right 3. So this point would be up 1, right 1, 2, 3, and we put another point, and then I need to put another line over here. I could do it again. I could go up 1 more and then right 1, 2, 3. And obviously without the graph lines, it's not perfect. But then I have my 3 points to be able to graph my line. So this went, just for a visual, up 1. And then it went right 3. So sometimes we have to, like the first thing that we have to do is actually get our equation in slope-intercept form. So it may be written in the form like we were using to find intercepts, which is standard form, and we need to move things around to get y by itself. Okay, so that's going to tie all the way back to 3.8. So that's why I said, 3.8 is getting us ready for stuff that's coming. This is the section that was getting us ready for. Okay, so if you had something, these ones aren't going to be graphing, but if it just says to find the slope and y-intercept of the equation, and it could give me something like this. Y equals 5x minus 3. This one is in the form y equals mx plus b. So m is my slope. So 5 is the slope, so m equals 5. And the y-intercept, which is b, is negative 3. So whatever sign is on that is what the intercept is, so negative 3. So that would be my slope and y-intercept of my equation. If I had one that's like this, 3x, or that's not an x, 3x minus 3y equals 12, then I need to first write it in slope-intercept form to be able to find my slope and my y-intercept. So, as a review, how do I get y by itself? What is the first thing that I need to do here?
And then divide by negative 3.
Nope, I want to get y by itself.
Minus
3. Minus 3x. So I'm going to have negative 3y equals negative 3x plus 12. So remember, I'm allowing you to skip that step of showing that you're subtracting 3x from both sides now. Okay? So I've done that. Now what do I do? Divide by negative 3. So when I do that, I get y equals negative 3 divided by negative 3 is positive 1. So I don't even need to write it. Just write x. And then 12 divided by negative 3 would be negative 4. So y equals x minus 4. Okay? So I'm looking for the slope and the y-intercept. Slope is whatever number is in front of x. What number is in front of x right now? 1. Okay, there's an imaginary 1 here. If you need to write it so that you remember, you can write it. Okay? And what is my y-intercept here? Yep, negative 4. Let's see. So let's see. I'm going to give you steps to graphing an equation like this so that we can make sure that you are aware. So steps to graph an equation. In y equals mx plus b form. So the first thing that you're going to do is rewrite the equation in slope-intercept form. If it isn't already written that way. Okay, so sometimes they will just straight up give it to you as y equals mx plus b. Sometimes they do not. So if they don't, that needs to be your first thing. If it is written in y equals mx plus b, disregard step 1. Okay? Step 2, identify slope and the y-intercept. So you should write something like m equals and b equals. Then plot the y-intercept on the graph. So that point's always going to be on the y-axis. And then lastly, use the slope to plot 2 more points on the line. Okay, and I'm going to note here that a positive slope means it is going up, then right, or you could say down and left. A negative slope goes down, then right, or up, then left. Okay, typically the way that I wrote it first is the way that we will go, but the farther you get in, what you may notice is happening is that may send your graph to be really, really big on one side, so to keep it kind of like fitting, we may want to go the other direction. So like usually in Algebra 2, I'm trying to convince them that like it's okay to go like the other way. Typically everybody wants to go right, which is fine, but also you can go left. You just have to be strategic about which way it's going. Okay. So this one would be, let's do this. So this first one would be up and then this way, or we can go down and this way. And what you'll notice is, by the way I've drawn this, this would give me a positive slope here as my end result. Okay, if you need that like visual, this would give me a positive sloped line. Okay. This other one, down first, then to the right, or up and to the left. I wrote that one like backwards, but it's fine. I wrote that backwards. Hold please. Up. I'm still writing it backwards. This one looks confusing because I have them flipped the way that they need to be written. Hold on. Down, then right, this one's gonna look weird if I draw that because I have them written backwards. Anyways, this one would give you a slope that's going down like this. Okay. I'm gonna get this for a second. That one's gonna give you a slope like that. That's a negative slope. But if I try to draw the little symbols, it's gonna look weird. Okay, anyways. The other thing, it's kind of weird that they throw this in this section. I don't know where they put the rest of it. I don't know if it's in a later section, if it gets its own section. I don't really know. But the other thing that's in this section, which we may or may not get to today as much, but 2 lines are parallel if they have the same slope. Does anybody know what parallel lines are? How would you explain to me what a parallel line is? Yep, lines that go basically side by side but never cross. Okay. So they may give us some different lines and ask us to tell if they are parallel or not by just matching if their slopes are the same or not. All right, let's move into some problems here. Identify the slope in the y-intercept of the line with the given equation. So we're finding the slope and y-intercept. So number 4, y equals negative x. So what would the slope be for this one? Remember, that's always the number in front of x. Yep, -1. Now, semi-trick question, what is the y-intercept?
Y. It is 0.
It is 0, okay? Because there is nothing there, okay? So if they don't have one written there, that means that it is at the origin, okay, at the point 0, 0. So this intercept would be 0 on that, okay? If they ever give you one that doesn't have an x, so let's just say it's y equals something, what would you say that the slope is? Like if it's just y equals 5, what would the slope be? 0, because there's nothing there. And that line goes where?
Vertical?
So if we had y equals 5, Abby said that the slope would be 0. Which way does this line go?
We would go, it's all positive, so it would go up right. A line go up right.
So ignore the slope for the moment. What does the line y equals 5 look like? We had this in section 2. Section 1. I don't know. One of those 2 sections. It's a horizontal line, right? That goes straight across. Hence the 0 slope. What would the intercept of this one be?
5.
5. Okay. So these are kind of like opposite type problems. Okay. This one didn't have an intercept listed, so it's 0. This one doesn't have an x, so the slope is 0. Okay. Just so that you've seen that. Number 6, y equals -7 plus 5x. What is my slope? 5. It's always the number in front of x, regardless of which order they write them in. Okay, if I wanted to rewrite this so that it's in your normal y equals mx plus b, I could just rewrite this equation as y equals 5x minus 7. So I just take the terms and I just flip them, but you don't have to rewrite it for this section. It doesn't ask us to do that. What is the y-intercept of this one? -7. Eight. Y equals -1/4 x plus 8. What's my slope? -1/4. What's the y-intercept? 8.
It's easy to make the 20 freaking 25. Don't have to choose numbers specific.
All right. These ones now want you to rewrite in slope-intercept form and list slope and y-intercept. Okay. So 12 is x minus y equals 6. So slope-intercept form is y equals mx plus b, so I need to always get y by itself in these problems. How do I get y by itself? Minus x, so I get -y equals -x plus 6. Now what?
Divide by -1.
Divide by -1. Technically, if you multiply by -1, you get the same thing also, but... So, divide by -1, I get y equals what?
-6 plus x.
So, x minus 6, we want it in slope-intercept form, which has to be y equals mx plus b. Okay, This previous problem up here, number 6, they didn't tell us to rewrite it. That's why I said you didn't have to, but these ones tell us it has to be in slope-intercept, so it has to look like this. Okay? Now, it wants the slope in the y-intercept. What is the slope? 1. What's the y-intercept? -6. Let's see. 14. -12x minus 4y equals 2. How do I rewrite this one? Yep, add 12x to both sides, so I have -4y equals 12x plus 2. Now what?
-4.
Divide by -4, and what do I get on the right when I do that?
Negative 3x minus half.
Yep. So always make sure you reduce stuff, because that would have given you a -2/4, so y'all reduced it to -1/2, which is good, but just want to remind you. What would my slope be here?
-3.
And the y-intercept?
-1/2.
Yep, -1/2. Are we okay on that? For the moment, at least. All right, we're going to move into graphing. So if you haven't been using your graph paper, this is where you're going to want it. If you're going to use it, like I said, not required, but I'm going to do it to make it easier to see what's happening here. So these ones say to graph the equation. So 22 is y equals 3x plus 2. So is this in slope-intercept form? Because that's step 1. Yes. So I need to find my slope in my y-intercept. What is that?
The slope is 3.
The y-intercept
is
is 2.
Yep, y-intercept is 2. So I'm going to set up my graph. All right, so remember, if you are not using graph paper, you have to put these little tick marks on here, okay? If you are using graph paper, it's sufficient to just have the graph lines. I know what you're talking about doing that. I'm just going to do these in case the graph goes away so that I can see it. All right, so I have a y-intercept of 2, so I'm going to put a 2 on the, I'm going to put a point on the y-axis at 2. That's what I was trying to say. So right here. Now, slope, remember, is rise over run. So whatever number is here, we always go up first, okay, or down if it's negative, and then right or left, okay? So this is a positive 3, so that would be the rise. That means I'm going up 3. And then what number is in the denominator right now? 1. So if you need to visually for your sake, if you need to write over 1 so that you remember it's got to go right 1, that's fine. So we're going to go up 3, right 1. So 1, 2, 3, and then right 1. Okay? Now, this is an example like I was talking about earlier. I said you can either go up and right or we can go down and left. So I don't want to make my graph any bigger up there than I already have, so I'm going to instead this time go down and back, okay, so down and to the left to do this one. So I can go down 1, 2, 3, and back 1, okay, and if your points don't line up to make a straight line, something is wrong, so that's a clue to go back and check and make sure that you've done everything correctly. But I know that this slope needed to be positive, or that it is positive, and my graph looks like it's going up the hill, so I know that I, assuming I plotted the points in the right spot, have graphed it correctly. Okay, the graph looks like what it should look like. Okay,
Is M the amount like you go up or down?
M just represents slope. So the number is rise over run. So this one was a whole number. So if it's a whole number, that's going to tell you how much you're going up or down, depending on if it's positive or negative. And then if like it's over 1, so that's going to either tell you, again, right or left, depending on what we're doing. And if it was something like 1/3, then we would be up 1, right 3. So the top number is always up or down, and the bottom number is left or right. The easy way to think about it is, quote unquote, in the morning, okay, you have to rise out of bed, so you have to get up before you can run, right? Some of you may try to run in bed, but you don't go very far, right? All right. 24. Y equals 2/3 x. All right, is this in slope-intercept form?
It's good enough.
Okay, y is by itself, right? That's kind of the key part. Y's got to be by itself. So what is the slope? 2/3. And what is my y-intercept?
0.
0. So, yep, we can pretend there's a +0 here on the end if we need to visually to see it. So I'm going to set up my graph. All right, so I have an intercept of 0. So that means that right here at the origin, I put a point because on the y, that's 0. Now, a slope of 2/3 tells me that I'm going to go up 2, right 3. Okay? So, I'm going to go up 1, 2, right 1, 2, 3, and I put a point. Okay? I'm going to go again up 1, 2, right 1, 2, 3. So then I just connect the dots as best as I can. If you want to use a ruler or something to make it straight, you can do that. And that would be graphed. And if you need to, like, it might be wise while y'all are getting used to these to actually write what is happening with your slope. Like, what is that slope telling you to do? So that as you graph it, it's a little bit easier to see. 26. Y equals -5/2 x plus 2. Is this in slope-intercept form?
Yes.
Yes, it is. So, what's my slope?
-5/2.
Yep, -5/2. And what's my y-intercept?
2.
2. What is this slope telling me that I'm going to do? Let's write that to the side. Down how many?
Down 2.5.
2.5. Well, no, 5.
Down 5.
And then
Across 2.
Across 2.
Right 2. Okay, because that's going to give me a negative slope. So negative tells me I need to go down. This is why I said it's important to just leave things as fractions, because otherwise it gets confusing. Alright, so I have an intercept of 2, so I'm going to put a point here. Then this tells me to go down 5, right 2. So down 1, 2, 3, 4, 5, right 2, 1, 2. And I put a point there. May have to extend my graph a little bit. I don't know if it's all going to fit. I'm going to do it again. Down 5, 1, 2, 3, 4, 5. Right 2, 1, 2. Ooh, I lucked out. I barely fit it. And then connect your dots. Okay, so just like we had in whatever section that was, 1 or 2, you have to put 3 dots on your graph. Okay, 1 will always be your intercept, and then you need 2 more. Okay, and I do look for that when I grade. Let's see, 28. -8x minus 2y equals 32.
You have to get the.
Yep, so this is not in slope-intercept form. So he said I need to get y by itself, so what am I going to do that? Add 8x, so I have negative 2y equals 8x plus 32. Now what? And what do I get when I do that?
Negative 4x.
I'm still writing down the problem.
I don't care.
It's minus 16.
Too bad.
Minus 16. All right, now, this is a problem that has larger numbers, right? What is my slope?
Negative 4.
Negative 4, and what's my y-intercept?
Negative 16.
Negative 16. Now, that's down pretty far, right?
Yeah.
So, this is a problem where I would suggest considering counting by something bigger than 1, because otherwise this graph is going to take up your entire piece of paper. You could do 4. The thing about it is going to be when you're going to the right and left, you're going to have to be strategic, but maybe this is a good problem to talk about that on. So, let's do that. Let's count by 4s. Counting by 2s would also be good. I know that most of my graph is going to be like way down here at the bottom, so I'm going to draw this kind of like off, because if I know that my intercept is down here at negative 16, I know that that's going to be, you know, down in the bottom, so I don't need to make it look like perfectly symmetric. Now, what I do need to do is I need to specify that I'm counting by 4s, okay? So down here, I need to put negative 4 so that I know that in every spot, I'm counting in increments of 4. Okay, as long as you label it at least on one part of the axis, that's sufficient. So I have an intercept of negative 16, okay? So 4, 8, 12, 16, so that's down here. Now, this is where I have to be a little bit strategic. What does that slope tell me that I'm doing?
Going down 4 and right.
Going down 4.
Yep.
And then going right once.
Down 4, right 1. Now, I counted by 4s on the x as well. So, when I go down 4, that's just one place because that puts me at 20, counting in increments of 4. But then I need to go a quarter of the way between here, okay, because this is an increment of 4. So that means that I basically have a point like right there. Not on the axis, but close to it. The next point, I go down 4 and right 1. I come down and I'm halfway between now. Okay? I need to fix this point. It's not. So, it's very steep. So it's fine to kind of pick your increments. We could have decided that I'm going to just count by 4s on the y and 1s on the x, but you've got to specify if you're doing anything other than 1, you've got to make sure that you put points on there so that we can tell what it is. Okay? All right, last thing really fast is determining if the lines are parallel. So tell if the lines are parallel.
Are we still going to graph these?
No, these ones we're just looking at their equations and seeing if they have the same slope or not. 32. Y equals 5x minus 7. And I have 5x plus y equals 7. Okay? So this first one is already in slope-intercept form. Because I'm trying to tell if the lines are parallel, all I need to do is see if they have the same slope. So all I care about is the slope. So what is the slope of this first one?
5.
Yep. So m equals 5. Over here, this is not in slope-intercept form. So what do I need to do?
Subtract 5.
So I get y equals negative 5x plus 7. So what's the slope?
Negative
Negative
5.
Negative 5. Do these have the same slope?
No.
No. So these are not parallel. They have different slopes. Okay, so it wants to know why. So you need to say they have different slopes. All right, one more. 34, y equals negative 0.5x. And then the other line is x plus 2y equals 18. So what is the slope of the first one, because it's already in y equals mx plus b?
Negative 0.5.
Negative 0.5. Over here, I'm not in slope-intercept form, so what do I do?
Minus x.
So I get 2y equals negative x plus 18. Now what?
Divide by 2.
So y equals negative 1/2 x plus 9. So what's the slope of this one?
Half.
Negative 1/2. Do these have the same slope?
Yeah.
Yes, okay, even though this one's written as a decimal and this one is a fraction, this is the same as negative 1/2. So these have the same slope. So they are parallel. All right, your problems are 3, 7, 11, 15, 21, 23, 25, and 27, and then 33. Okay. Tomorrow we're going to do worksheets on graphing because you can never have too much graphing practice, which I'm going to go make copies for y'all that aren't going to be here really fast before the bell rings. We have like 5 more minutes. So you can probably get a couple of these done.